In this work, we present a technique to estimate magnetic filling factors for spots, plage, and network regions using S-index and photometric observations. Two implementations of this technique are demonstrated on the Sun and may be applied to stellar targets. The first implementation is purely analytical and may be applied to other types of stars, but requires a strict observational cadence. The second is based on machine learning techniques and is only applicable to Sun-like stars, but is time-independent and therefore places no constraints on the observational baseline. Both techniques reproduce full disk measurements of the filling factors for each magnetic feature. For more information, check out our poster and watch for our paper to be submitted soon.
Hi, my name is Juan Camilo Guevara, and this work is about tracing small-scale dark features in solar ALMA observations. Features like this one inside the purple box. We do this because these features may be post-shock signatures. For instance, this is one example out of 502 that we found in these particular observations, and as you can see, the post-shock region is very well defined in the time-distance plots. And also the difference temperature between the ambient and the post-shock region is about 900 Kelvin. For all the 502 features, the average difference temperature is about 540 Kelvin. This falls within the range that have been found by other colleagues in degraded simulations. The next step is to use these results to quantify the energy transfer due to propagation of shock waves in the solar atmosphere. Thank you.
Hi, I'm Soumya Krishnamurthy, a Marie Curie Fellow at MPI for Solar System Research in Göttingen. The emission in the near ultraviolet calcium-2 HNK lines, often quantified via the S-index, has been serving as a prime proxy of solar and stellar magnetic activity. S-index was suspected to be influenced by the inclination angle between the stellar rotation axis and the direction to the observer. For example, two stars with exactly the same magnetic activity but one observed equator-on and the other pole-on would have different S-index values. To quantify the inclination effect, we developed a model to calculate S-index using the state-of-the-art surface flux transport simulations and non-LTE radiative transfer calculations. Our model facilitates a better understanding of the link between the inclination and the S-index, thus enhancing the diagnostic potential of the calcium-2 HNK emission measurements. Thank you.
Hello, I'm Raffaele Reda and I'm a PhD student at the University of Rome Tor Vergata. In this work, we have studied the long-term relation between solar activity and its near-Earth effect by looking at solar wind properties. To do that, we have used long-term average data of calcium-2K index and two solar wind harmony parameters such as speed and dynamic pressure for the last 5 solar cycles. No clear correlation seems to exist between them over the entire period, but we found an anticorrelation for solar cycle 20 and 21, where we observed a change toward the correlation for the last 3 solar cycles. We found a time lag between calcium-2 and solar wind parameter, but the lag is not constant over the time. This is a typical characteristic of time series which show different periodicities. Once corrected for them, we found a correlation relation which is valid for the entire period. The advantage to use a chromospheric proxy as the calcium-2K index is that the relation found from the Sun can be easily extended to Sun-like stars to link stellar variability and stellar wind property. Thank you for the attention and thanks to the organizers for giving me this opportunity.
Our goal is to understand the physical process driving active region emergence. Active regions are a key component in converting toroidal to poloidal field in the solar dynamo and the dynamo of Sun-like stars. We have put together a catalogue of 185 emerging active regions observed by the Solar Dynamics Observatory. Here you are looking at the line-of-sight magnetic field of 2 active regions from our sample. By analysing the motion of the leading and trailing polarities in relation to the surface flows, we have come to a series of results that all point towards the fact that convection plays an important role in the emergence of active regions, particularly at supergranulation scales. This is in contradiction to thin flux tube theory.
Hi, I will talk about effects of flares on solar high-degree helioseismic acoustic mode amplitudes. We first analyzed the halloween flare using MDI data to the SM5 region as Maria did. After correcting for disk position and Dutch cycle, We did not find any variation in the mode amplitude. Next, we analyzed all HMI regions with strong flares detected in the HEC database. 50% of the strong flare regions have MAI smaller than 100 Gauss. Looking at the relative amplitude difference, strong flares minus without flares at a given MAI range, we find a decrease in the mode amplitude when there is a flare. Around flare regions, there are on average more active types. As shown in our previous work, the amplitudes are attenuated by nearby active regions. So when taking this into account, we see no variation larger than 10% in the mode amplitude. Also, we show that great care is required in analyzing the flare regions and the comparison one in an ever-changing sun. For more details, see our paper, and thanks for the attention.
Hi, this is Hugh Hudson reporting on the Carrington solar flare. Actually, the first multi-messenger astronomical transient ever recorded, 1859. Not, however, so extremely powerful as to be called a super flare. Since then, we've had other comparable events. But more than that, in the prehistorical record from carbon-14, we've got these tree ring events that Miyake et al. Discovered. The point here is just that they last, the carbon-14 record lasts for a few years, and so it's possible to have several solar flares during one of their episodes. So that's the story. Here's a sunflower, and the haiku reads in English, multi-messengers, himawari wannabe, Carrington extreme, or in Japanese, sora wo biru, himawari no yume, Carrington. Thank you.
The planet Mars lacks an intrinsic magnetosphere due to the absence of a once active dynamo process that existed billions of years ago. In this study, we present results of 3D compressible magnetohydrodynamic simulations of the interaction between the wind from a Sun-like star and a Mars-like planet using the star-planet interaction module. A non-magnetized planet is considered, which hosts a very thin atmosphere and the stellar wind follows magnetized shock conditions. An imposed magnetosphere is formed around the planet along with strong plasma shades in the magnetotail region. The global trend of the simulations compares well with observations from NGS and MAVEN missions. The study is important from the perspective of planetary habitability and finds implications in exploration of habitable planets in the solar and exoplanetary systems.
Hello, I am Katerina Dineva, and I would like to point your attention to this project where we aim to characterize the chromospheric activity cycle. We use two kinds of indexes, spectral and image-based. Spectra is obtained Pepsi spectrograph, and images are delivered by the chromospheric telescope and SDO IS suite. These indexes are usually studied separately. However, their combined analysis yield an insight into the surface morphology which drives the disk-integrated spectra, from which we compute the powerful activity indexes such as the S-index. For more information on how we do that, the database and the analysis techniques used in this project, please see my poster at the website. Thank you very much for your attention.